Hi, this video is about calculating Fleiss Kappa. Fleiss Kappa is used for calculating the inter-rater reliability. Examples: you are analyzing a scale and you want to know how different raters view each item of the scale, maybe in terms of clarity. Now here what you have around in this example 10 items. On the horizontal axis we can say we have the categories. Example, a rater strongly disagree that the item is clear to strongly agree the item is clear. So in this example we have 5 categories, and one other factor is the number of raters. In this example the number of rater is 14. Let us see how we can calculate the Fleiss Kappa. Well, calculating the Fleiss Kappa, two fundamental concept which you should keep in mind is the proportion of agreement on the ith item, that is first item, second item, that will come in the row, and the proportions of agreement on the respective category. Example, proportion of agreement on strongly disagree category will come in the column. Now let's see how we can calculate the agreement of items. Now we will be calculating it in row, and if you look at it here, there is a formula for doing it. So basically what we do is that we square each terms. I'll put up a formula here. Take the first row's first column, then I square it, add the second one to it, I square it, then I add the third, and so on. Now I have squared the items. Now I need to subtract it from the number of raters, that is the n in the equation. Number of rater is 14. I divided it by n into n minus 1. N is 14, n minus 1 is 14 minus 1, that is 30. This calculates the proportionate of agreement of the each item. I drag it up down, so it calculates the proportionate agreements of all the items. Now we need to calculate here the total, because we need to calculate proportionate of agreement on the each category. So here what we do, we calculate the total number of scores on that particular category divided by the number of items, that is 10, and the number of raters, that is 14. Then we drag it for all the categories. Now I have with me two things, that is the agreement of each category and agreement of each item. To calculate P bar, what I do, I average the value from item, that is the proportionate of agreements from item 1, that is this, to here. That's calculated P bar. PE bar, basically this term is used to calculate the randomly if someone is assigning the scores to these items, how would these um, items reflect. That is done by squaring up the each of this category squares. So you can see this category squares are squared, and Cohen's kappa is p bar, that is this term minus pe bar. That means we reflect the non-random component divided by what is being available, that is from 1 minus pe bar, that is the score which is outside the random component. That score will give the Fleiss kappa. In this case it is 0.20. Fleiss kappa from 0.4 to point and above, it's considered to be moderately good, and above 0.7 is fantastic, 0.7 or 0.6, but till 0.5 we can say above 0.5 the inter-reader reliability is good. In case someone wants to eliminate the particular item, also it can be eliminated from the proportionate scores of the item level scores. If you see in case if our Fleiss kappa was more than 0.6, and individually in case if a particular item is having a agreement among the raters of a particular item around 0.2 or 0.1, you can think about eliminating the item. However, I would advise, a word of caution would be to look at the item from the a priori theoretical point of view instead of just relying on the statistical results. Thank you.